talking about something different. I was saying if, no, I was saying if you want to use the text for the poll, you can just grab it from there, or I can grab it from there. Hello, welcome to TEAS. Good morning, good afternoon. I guess good evening might be there, depending on where you are. Happy you've made it. I am Lou Berger. I'm here with my co-chairs, Pavan and Oscar. And we also have our tech advisor, Adrian, in the room. So we have a good showing of people. Thank you all for joining. This is an IETF meeting, which means that we have processes and rules related to our activity here. This slide is our note well, which is talking about contributions. Yesterday, there was some chair training that said we should just leave this up here for a moment and not give our commentary and give an opportunity for other people to look at it. I think there's a lot of text here. So if you're not familiar with this slide, please jump on the note well on the bottom. If you type IETF note well into Google, you'll find it. It's really important to understand what rules govern your contributions to our work here. We also have guidelines governing our conduct and how we treat each other. I don't remember if there was any specific don't say anything here, so I will take an opportunity to say something. It's important to treat each other with respect, to remain professional, even when we have good, heated technical discussions, which is the reason we get together. So it's perfectly okay to have differences of technical opinion, but keep it professional, keep it on point. If you do feel that you're not being treated properly, we do have a team, an ombudsman team, excuse me, need more coffee clearly, who are there as a resource if you do feel like you haven't been treated appropriately, and that's inside a meeting or outside a meeting. For those that are remote, you've already figured out how to be here, so that's great, thank you. For those in the room, we ask that you scan in. We do expect to do a couple of polls today, so it's really important that you do scan in, and that's a way that you can participate in those polls. Also, to keep it sort of equitable between those who are in the room and those who are online, we're going to be managing the queue via the tool. So we really ask you join either by scanning or using the full application on your laptop. So I mentioned already the queue control. What I didn't mention is joint note-taking. So as we have done in previous meetings, we're using the notepad. There's a link inside on Meet Echo. There's also the link on various pages. Please join and help us capture the discussion that we have. You don't need to capture the words of someone presenting. That's what YouTube's for. But the main points and any agreements we come to, we think it's really important to capture that. So if you get up in the mic and make a point, go back and check that it was appropriately captured. Thank you. All material is online and available. It's actually been there for most of it for a couple of days. The agenda has not changed from what was previously announced, so no last minute shuffles or surprises. We have a pretty full session, although we do have a little time, so we'll probably be a little flexible in managing the timing. If we're having a good discussion, particularly on a working group draft, we'll allow a little more time on that. And with that.
Okay. So now a very brief update on the document status. Later on, Pavan will go into more detail. So first of all, yes, we have a set of documents that are in the editor queue or are waiting for our AD to go ahead. And here we are not expecting people in the room to do anything. So the special attention comes to several documents. So first of all is the update, the data types update. This is the one that is, let's say, a little bit blocking other documents, so it has some still some open issues. So it's just now waiting for the authors to submit the version, so we can unblock. So just please work on this to work to move forward. And then we have some documents that are just waiting on this update. Okay, so that's no problem. You just, when the other unblocks, they can go ahead. And the slice MBI has some open issues also, so that's and also waiting for the update. So authors should take care of that. And also in the layer 3T topology, there are also some open issues that need to be addressed by the authors. And also we have the 5GNS MPLS that we'll have the discussion later. We recently adopted the T-topology profiles and the topology filter. The IPR was completed, and now we have just started the IPR poll. Okay, so you have 3 weeks to answer to that poll. Yeah, we have the control. So this was the data that was submitted, and after the discussion that you have the thread on the list, the errata was rejected. So any details, just go to the list for the details. Forward. Okay, so here we had a couple of virtual interns. So the first one was about the NRP selector. We had very good feedback in that intermeeting. You have here the minutes with all the details of what was discussed, and there will be follow up on the mailing list of the points that were raised during the intermeeting. So we expect to advance. And the second topic that we had, there was a meeting between NMOP and for the digital map activity and the topology. So how can we use the T-topology model that was produced in TEAS also for the purposes of the digital map? The discussion that started in the intern, what you can see also the minutes there, has continued in a side meeting this week and is expected to continue. So there is still work in progress to see what is the best way to advance. So liaisons. So first one, we have an incoming liaison that has been sent to several working groups. Please take care and read it. And if any of the people in the room is willing to prepare or to has anything to say, send it to the list and we will prepare the response. Otherwise, I think there will not be any response sent. So this is contribution based from the people to this IMT 2020. And then we have a set of liaisons that have already been answered for the framework for the liaison on the slicing, the first two of them. And the very first one is just we responded with the publications of the framework. So we already informed. The second one, if you remember, we have one of the working group documents that refers to 3GPP technologies, and after some discussions, we decided that the best way or the best approach was for 3GPP to review the document and confirm that everything that we are saying is okay, because the document contains a lot of text that is not coming from IETF, but comes from 3GPP. Hence, this liaison was sent. So we already gave them time also to have their meeting and to provide the feedback. And the last one is the info for the OTNT standardization work plan, and this is now been in response. Okay, so just a final reminder of the IPR disclosure process. So here, even if it's not required, here we encourage, and what we usually do is in previous to the adoption of a working group document and in the working group last call, with all for any IPR. So if people have maybe forgotten to disclose any APR, or have time. So remember that there is this process, and please follow it. So GitHub. So we still don't have all the documents tracked in GitHub. So we still have some individual GitHubs around. So here, just remember that we have this official GitHub. So if you want the document or your Git where you store the document and with the issues and so on to be stored in the official TEAS working group, so you have it here. Contact us if you want to move the repository. I think there is, with Tarek, we started to do the migration, and then for some reason we did not follow up. So I think this one is to follow, and other documents the same. So as long as once you adopt the document is adopted, also please transfer it. But just as always, just the consensus is on the list and not in the GitHub. Okay? So use the GitHub to track things, but consensus please on the list. Okay. So here we want that the authors of the working group documents, that they in advance to the every meeting they provide a status. Okay, so just what has changed, anything that is not solved, and also you need the working group to, or you need the group inputs, or you need the chairs for advice. So here, either you do a report during the IETF session, or just send an email to the working group and with the status. Okay, so please, all the authors of working group documents, please follow this process. And now I leave it to you.
As the slide suggests, this is Lou's last working group session as TEAS working group chair. I'll use the platform to say a few words to Lou. I've had the privilege of sharing the responsibility of serving this wonderful working group with you for 9+ years, so I'm grateful for that. Thanks for being a great mentor, for letting me have the time and space to grow into this role. The honesty and integrity that you bring to the table for every consensus call is something that Oscar and I will try to emulate as we continue to serve this working group. And again, a big thank you for agreeing to be part of this working group's illustrious tech advisory team. Lou will be joining Adrian as a tech advisor.
I would also like to thank Lou, because I mean I have enough time to catch up. Otherwise, I mean, just jumping in, it has been very difficult. I hope to have learned a lot of things from you. Thank you.
So we've had 4 ADs in Lou's tenure. So John has the privilege of representing the ADs.
Yeah, Lou tends to wear ADs out, apparently. I think you guys said most of what I was going to say anyway, but one of the best things you can say about a leader is that they work to bring new people in and make themselves obsolete, or at least able to retire. So, it's really says a lot of good things about you that you did that. And thank you for making it really easy to be an AD for this group. That's it.
Jim?
Yeah, so I just wanted to say, I hope, Lou, it wasn't something I said. But again, thank you so much for that. I'm certainly looking forward to being responsible AD for the working group moving forward, and thank you for all the work you've done. Obviously, I've followed in the background, not as AD, but just out of interest in the technology. So again, thank you.
Well, thank you all. And it's really been easy working with this group, because it's such a great group of technical contributors, and also people that are generally easy to work with, which is nice. So that's been great. I'm going to go back to one thing that was said, I'm not retiring. The reason for this is, you hear that it's been planned for a little while. It's to free up time. So maybe I can spend a little more time as a contributor. So I'm not going away. I'm not retiring just yet. That'll happen eventually, but not yet. And I will continue chairing other groups, but really been great working with this group. I think you're in great hands. And the work of this group is so important. I continue to think it's so important. I went and looked through the history of the RFCs published. It's interesting to see the shift from distributed to controller based. That's really very interesting to see that shift over time. And the work we're doing right now particularly on slicing is really important to the industry. So keep up the good work, and thank you for letting me be here for so long. So we should move forward.
Okay. Next on the agenda is working group document status. My favorite slide, the 29 documents on the slide. We have 5 documents that are in what we call publication requested stage. They are in they are at varying stages of the ESG processing phase. We have 5 other documents that are on the agenda today, so that leaves us with 19 documents, and the status of each of those 19 documents is captured in this slide deck. We have 6 documents in what we call post-working group last call stage. There are 3 of them, the Yang T, the path computation Yang, and the network slicing service Yang. These 3 documents are dependent on RFC 8776 update, and I will dwell a bit on the status of that document in a later slide. I will not be walking through the status of each and every one of the documents covered in this deck, but as usual, I'll double click on a select few and dwell on them a little bit. For the remaining, please do go through the slides and also check the status reports that are sent to the list. And if there are any questions, please post them either here or send it to the list. So with that, let me jump to slide 3. So this is the ACTN performance monitoring telemetry autonomics Yang document. The authors believe that the document is ready for last call. So please do review this in anticipation of an upcoming working group last call. The next document that I would like to draw your attention to is on slide 8. This is the document that talks about realizing network slicing using the notion of network resource partitions. There was one revision published for this in May that addressed a few editorial comments that were made earlier on. We did have an interim on May 29th that focused on the requirements of NRP selector. We did receive some great feedback, and there's been some discussion of the list as well, and all of this needs to be discussed and incorporated into this document. So please be on the lookout for some discussion on the list and also text in the newer version of the document. Let me now go to slide 9. This is the RFC 8776 update document, the T types Yang. We did take revision 10 of this document through working group last call. Revision 11 was published addressing a major chunk of the comments that were received during the last call. Revision 12 was published just a few minutes before this meeting, which should address another set of comments. We still have a few comments from MED that are unaddressed. Those are captured in the Git link here. Most of these comments are still editorial. There are, I think, a major chunk of those reference text from the original RFC, so I guess that's taking some time. There is, I think the authors do realize that there is some urgency with getting this done, given the dependency that the other documents have. So please do expect to see some. I think if there are any items that would need working group input, ITLA would send them to the list. But yeah, expect to see some updates on this fairly soon. There are 3 other Yang documents for which the authors believe there are no more changes to be made. Those are the Young RSVP document and the SF topology document and the SRT topology document. So please do review those as well in anticipation of last call. Those should get lined up for working group last call as soon as the first batch of Young documents go out the door. So those were the documents that we wanted to draw your attention to as part of this deck. If there are any questions on these or any of the other working group documents, please do post them here or send it to the list. I don't see anyone lining up. So let's go to the next one. That would be Christoph.
Good morning to everyone. I'm Krzysztof Szarkowicz from Juniper Networks. I will present the update on 5GNS IP MPLS draft on behalf of my co-authors. Next slide, please. No, it's not working. Anyway, all right. Workgroup last call was for the draft revision 04. Then we received some updates or some comments, and then we issued revision 05 in April 24. And there were changes to address the comments raised during the workgroup last call, mainly from Ji and Xiong, and basically to ensure better alignment with the application draft. Then they use consistent terminology. We have some inconsistency in the terminology, so we make changes here. Then clarify as well customer of end-to-end slice, customer versus customer realization, and removed NRP, so network resource partition, from the list of transport lanes candidates because we received the comments that NRP is not part of the current existing technologies that are being used by the operators. And the draft is based on the current existing technologies. So how to use the current existing technologies to implement the slicing. So we removed NRP from that. Then we received suggestions to remove addressing example to a separate document. So we provide some addressing example for the slicing, IPv6 specifically, IP4 as well. But authors explained that this is not about making recommendation, but this is some example, just exemplifying a local design that can be used by the operators using existing tools. And then we didn't receive any further comments on this, so no follow-up since then. Next slide, please. Then we received further comments, and we implement this additional comments in the revisions from 06 to 08, so 06, 07, 08. The last revision, the current revision is 08. It was released in June 24th, so approximately 1 month ago. And then we received very detailed comments from Adrian. So first was related to the document structure and the new content. So we made many changes, to enhance this overall structure of the document. And then most of Adrian's suggestions were taken into account, including scalability discussions and some others. Then there was the questions regarding keeping or removing the appendix, summarizing the 3GPP technologies which apply here to the content of this draft. And the decision was to issue the liaison statement to 3GPP, and we are waiting, as I understand, for the response. I think until end of August we supposed to in August we're supposed to get response from GPP on that. Then there was some comment regarding mapping and unmapping between the different domains. So we clarified in the draft that binding back a packet received from the transport network domain is not in the scope of this draft. So this is out of this draft, and the classification will happen on the next domain, which RAN, for example, RAN domain, whatever. Then there was discussions a lot about transport plane versus network resource partition versus filter topology slice. We used initially in our draft transport plane to describe different planes or different transport underlays that today are used by the many operators. For example, one kind of set of tunnels which is optimized based on the latency metric, and another set of tunnels which is based on the normal IGP metric that can be implemented using different technologies available today. For example, RSVP tunnels or segment routing tunnels or flex algo or whatever. So it doesn't include any partitioning of the resources and so on. So initially we used for this term transport plane because it was used in some other drafts as well for similar aspects of the transport technologies. We received the comments, that maybe this is NRP, maybe feeder topology. So NRP, as already mentioned in the previous 2 slides back, I think the version 5, we removed NRP from the text of the draft. And then we changed the transport plane to inter-PE transfer plane, So, to provide the connectivity when MPEs. But of course, maybe if there's a better term for that. So for example, layer 2 VPN, layer 3 VPN data models, they're using in the models itself underlay transport for similar aspects of the transport. So maybe we should use underlay transport. I think that will be some further discussion on that. And since then, we didn't receive further comments. Next slide, please. In version 7, we addressed the comments from Deborah about the addressing. So as I mentioned, we put some example address in the text of the document. And we received that Deborah acknowledged that is no clearer on addressing being local, but still the question that this might not belong to existing technologies. But of course, allocating the IP addresses and configuring the IP addresses on the interfaces, on tunnel endpoints and so on. This is common practice that is used today. We just provide some example of address allocation in that. We didn't receive any further comments on that, so we consider this point as closed as well. Then in revision 8, there was a question for clarification from Greg about OIM. So whether there are gaps in RFC 72, 76, or how to assess isolation objectives. So we clarified that there are missing tools, for example, SFC, service function chaining, but the scope is to leverage existing tools. So this is what the moment. No changes were needed in the document itself. So we get acknowledgement from Greg. So we consider this issue as well as closed. Next slide, please. And the next steps, the Artus actively engaged with all reviewers to address their comments, make changes. So we made a lot of changes through this revision 6, 7, and 8, and provide rationale for not making changes if we decide not to make changes. And the authors believe that version 8 is ready to be sent for ISG for publication. Thank you very much. And if there are some questions, I am open for questions.
Hey, Christoph, it's Adrian. You invoked me. You rubbed the magic lamp, and so here I am. No follow-up from me since 31st of the 5th. Were you waiting for any follow-up from me, or are you just saying, I haven't sent you a birthday card?
No, we consider that because if there is no further comments, that we address all your comments that you sent to us.
Yes, you've addressed them. I'm not 100% happy, but we're going for consensus here, I think. So, I won't die if this gets published.
Okay, Jedong from Huawei. Yeah, thanks for all this work. Yeah, I think the draft improved a lot, and I will give another brief review of the latest version maybe after this week. Thank you.
Okay, thank you very much.
Hi, Greg Mirsky, Ericsson. Yes, thank you for responding to my questions, but I would expect that something will be noted in the text to that. So not only just for my information, but for future readers. And personally, I think that it will be helpful if this document goes through another period of review.
All right, all right. So can you send the comment written as well so we can address that?
Yes, thank
Thank
you.
you very much.
Whatever you responded would be helpful if it's reflected in a document.
Okay.
Okay, don't see anybody else. I do have a comment. This is regarding the inter-P transfer plane. I've read the section. I think we can reword this section without actually having to coin a new term for that. I think all it's talking about is service mapping using traditional means. Consider rewriting that section without coining a new term. I'll also send some suggestions.
Yeah, but we have some figures as well to show the mapping and the figures we have as well in the title. So it would need to be reviewed how to address that.
Yeah, I think your point about reusing an existing term, if you need the term, is really a good one.
Yeah.
Underlay transport seems
Right.
pretty reasonable.
Okay.
I found the new term a little cumbersome, confusing.
Right. Okay. Yeah, if underlay transport is the agreement, we can rework this document to use underlay transport term. That's okay. All right. Thank you much then.
Bo, are you here?
Yes. Can you hear me?
Yes.
Okay, thanks. Then I will get started. My name is Bo, and I will present this NLP's young modules on behalf of all my co-authors and contributors. So I will give an update of this NLP young model status. Next slide, please. So the status of this NLP young modules. This working group draft was adopted in last IETF meeting, and we presented in TEAS interim meeting, and just before this meeting, we posted 02 version. In this version, we addressed most of the open issues raised during the working group adoption. And we thank everyone for your valuable comments. Tom Patch, Adrian, Matt, Luis, Jason, Italo, Olga. And the changes we made are mainly two parts. One is about young model optimization, and the other is some description improvement. For young model changes, the first major update is PHP profile list, which I will explain it detail in the following slide. This is from Matt and Louis' comments. And the next major one is about NLP monitoring. We add a new container to hold the NLP specific node link attributes augmentations on the 8345 following the layer 3 topology augmentation practice. And the other some young improvements made raised by Matt. And for the text description, we make the term consistent with the RFC 9543, the network slice framework about NLP definition and network slice service terms consistency. We also add a new section to clarify the NLP network model and device model usage in the context of network slice controller, network controller, and devices. And we also add a description of NRP policy 3 modes, and also the resource reservation descriptions. These are just all this clarification we add are from the upstream network slice framework, network slice IPM+, and NRP scalability. They are all working group drafts. And we also fix young examples in the in appendix. Some open issue we still have, we like to get the working group feedback. The first one is about the normative reference of topology filter draft, which is currently in the process of working group adoption. The suggestion from Matt is that we better remove this normative reference, and when it's stable to get it back. But at the this draft is in the process, we think we can keep this as is when the draft is adopted. And the other issues are related to young models, and I will discuss them later. Before I go into the specific details on the change and open issues, I will first repack the overall definition of NLP young models on the configuration part, which gives some background on specific issues. Again, as I said earlier, NLP young models are designed based on the 3 upstream documents. The network slice framework define the general NLP definition, gives the definition here. It's about the subset of software queuing, scheduling resources, and associate policy on the set of links in the underlay network associated with NLP. Yeah.
Bo, do you want to take questions now or after?
Yes, please. If there's, I like to hear.
Ketan Talaulikar, Cisco. A question or a suggestion. For the NRP policy, we have a NRP ID there. Could we consider renaming it to NRP policy ID, perhaps, just for disambiguation from all the other things which we discussed?
Actually, I'm going to talk about that a little bit because NRP policy is quite a specific design in the network slice NPM+ that the NRP ID is not actually it's a ID that be instantiated triggered by this policy. So this is a management ID. I mean the network, the NRP instance ID, not the policy. Policy. The name here is for the policy. Am I clear on that?
Yeah, I think Ketan, your point is noted. Maybe you can start a thread on this. I think what Bo is trying to say is by using an NRP policy, you're instantiating an NRP, and the ID that's specified here is the ID of the NRP that's being instantiated.
In the management plane.
Right, management control plane, yeah.
Yes. Okay. Then I think then we're talking about the NRP policy here, and because the general definition in the network slice framework means different technology implemented in IP or MPS or Spring network that will be realized in control plane and data plane different mechanism. And also the network NRP scalability also define the relevant NRP IGP forwarding mechanism. So based on these three documents, we define the NRP Young model components, where you can see on the Young tree that such as resource reservation, topology, they are quite straightforward, derived from the NRP general definition. And also some like NRP policy and selector and PHB. These are defined in the network slice at PNPS. And you can see on the right-hand side, this is a figure we added in this version to show that the NRP network model and NRP device models position relationship with the network slice controller and network controller and devices. And you can see also here, see that in the Young tree, in the top container is about policy profile list. Here we added in this version to address the PHB issues raised by Matt and Louis. And the other two open issue is about the NRP device. Matt seems think we currently augment the network. This route seems not a device models route because we augment 8345 with networks. This is not clear to a device model. And the other is about network, the selector. I will go into detail in the next slide. So this is a newly added PHB profile. Louis read the comment that he's not the previous model seems not clear whether the PHB is a multiple one for a particular NRP instance or it's just a global one. Here, and also Matt made the comments that a PHB profile helps to reuse the standardized PHB, and leaf reference can be helpful here. So we check the previous definition in the individual draft on the NRP policy draft. We think the original design is quite useful, so we borrow here, and we use leaf reference for the global NRP and also the link specific PHB here. So you can see that this PHB is used for the together with NRP selector. The selector can identify the NRP specific resources and will also apply the PHB policy here. So I will move on to the open issues if there's no comments on this PHB definition. So Matt made the comments on the NRP device model augments the network model design. His comments is about that this current our NRP device model is not device model. It seems not the right route. What my proposal here is that we think that networks is not that clear in the context of device configuration. So we I suggest that we can reuse a grouping of NRP network model rather than augment 8345. So that's the proposal here. And if there's no comment on this, I will move on to the next open issue. That there's also a comment from Matt is about this NRP selector. The comment is about do we exclude the combination can be used as selector, which referring to the IPv6 part that he's mentioned maybe dedicate as a v6 seed or IPv6 destination derived can be used together. For me, that the network slice IPMPS and also NRP scalability doesn't have these kinds of use case of combination. So at the at this time, I think we can if Matt can propose some use cases to network slice IPMPS or scalability to see whether there are some real use case that can be used here. So that's all. Oh, is Ketan again?
Yeah, Ketan
Okay.
Talawar, Cisco. I think it may be a bit too early or difficult to come up with all types of selectors and what all combinations is required. They may not be even covered in any of those documents. It will evolve. So I'm wondering if there is a way to do this in a manner that is extensible. I'm not a young expert to provide suggestions, but I hope in the working group somebody can help come up with something like that.
Yeah, this point noted. I think this is still early days. I think there are other documents and various other working groups that are evolving as well. But yeah, this is work in progress. So any feedback on how this needs to be modeled would be useful.
Chidong from Huawei. I see that in this model, actually, there's a choice like using ACL to as a matching rules, so that can be very flexible.
Yes. We can think all these kinds of combination and see whether it's flexible enough to coordinate to fit the requirements of the two drafts mechanism definition. So that's all from the open issues. And so the next step for this draft is that we will make coordination with the two working group drafts solution definition, and we welcome any reviews and comments, and especially the comments to see whether we have the raised during working group that we can close. So that's all for
Okay,
this.
thank you very much, Bo. So I expect that to follow up in the list the different points that you have written today, so we can get updates and get consensus on them. I think we need feedback from the working group to close those.
Okay, I will send out the updates and ask the
Okay, so
the feedback. Thank you.
Okay, good morning. This is Jiedong from Huawei. I'm going to give an update about this draft on the scalability considerations for the NRP on behalf of the co-authors. Okay, a little bit recap of this network slicing and NRP. I think people in this group are very familiar with these concepts, so I'll be brief. We know that the general framework and the concept of an IETF network slice has been described in the published RFC 9543, and it mentions that network slice services can be mapped in and the network slice connected constructs to the NRPs in the underlying network. And an NRP consists of a set of network resources and is associated with a filter topology and can be used to support one or multiple network slice services. And as the number of the network slice and the number of NRP view increase according to the different deployment scenarios, the scalability of NRP is important. So this document provides the design principles and also the considerations about the scalability in both the control plane and the data plane. And we also have some scalability optimization suggestions in this document. So here are the updates in the latest versions. Firstly, we published the text on the NRP scalability design principles in the section 3, according to the feedback received on both online and offline. And in the appendix section, we also added some examples of network slice realizations with different technologies and their scalability implications. There are also many editorial changes and the update to the references. The next step for this document, I think, is to reach the consensus on the scalability design principles so that we can, and also if there's any other additional considerations or principles we want to add about the scalability in terms of the control plane, the data plane, can be added to this document as well. And then we can use this document as a guideline for the protocol work for the data plane, the control plane, which are required for the scalable NRP solutions. Then we can move this document towards working group, let's call in the next step. Here, we'd like to give an overview of the scalability design principles in this document. Here, this is not the full text. If you want to check the text, just please go review the document. Here, and I will not read everything here. Just want to summarize what we have in this design principles section. The first part is we have some text about how we can achieve the scalability in the control plane. That is by sharing the topology or filter topology among multiple NRPs so that the SPF computation overhead can be under control. And second part is there's also text about identifiers in the data packet. We need identifiers of the path, the NRP, and the topology, but they may be using separate fields or using the same fields or may even overloading existing fields. These are part of the solution design. This is there's no specific constraint or limit in this document. The document also talks about NRP instantiation, the NRP specific path computation, and also again, NRP identifier in the data packet is required to indicate the packet and the associated NRP. Also some text about the steering the services to the NRP specific path using the control plane and the data plane mechanisms. If you want to check the details, please go to the draft. And text in the red color is something we changed in the latest version. So if you have any questions, just please ask. This is the second part of the design principles. Basically, we talked about some requirement about the solution on the scalability. We should not attempt to constrain the operators in their deployment choices. They may choose to use a solution which not be that scalable, but maybe suitable for their use case. And at the same time, we need to design a more scalable solution which can be used in all scenarios. Again, there are the text in the red color are the changes made in the latest version. More specifically, we have the text about the control plane. If we want to use the control protocols for NRP specific information, we need to, it will be important to isolate this information from the existing routing information so that there will be no impact on the scaling and the stability. And I think that's mostly what I just said in the updates. Kenan, you want to now? Okay.
Yeah, Ketan Talolikar, Cisco. Yeah, it's on this slide. So we have had discussions offline. I have concerns about, there is a kind of a contradiction there. We're saying it does not need to be involved. And then we say, if they must be involved, then do. I think it's a bit important to.
Does not have to be.
It does not have to be, but when they need to be.
Yeah,
So let's clarify that,
yeah.
yes or no and what exactly. The
Okay.
concern is when we put things in the protocols, IGPs, BGP, we will stress the scalability of that. I mean, depending on how much NRPs and what is to be used. Example of BGPs, how is this information distributed to, BGP is a spray protocol, right? So we have had some discussions. I have concerns about this. It would be good to try and actually come up with what is the exact things that it's okay to add and what is not okay to add, especially because on the previous slide, we are saying that this will be the basis for driving protocol work. So let's spend a bit more time and discuss maybe on that.
Yeah, I agree. We can have more discussion and polish the text here, but this text is not specific to any routing protocol. It's a general
It's for
discussion.
all routing protocols, and
Yeah,
that's where we have to be careful.
But the point is here is that we should not impact the existing stability and the functionality of the routing protocol. Maybe we just, if needed, we can avoid this kind of impact so that it's kind of acceptable when needed. Because for some scenarios, as we already noticed, that using the management plane for some of these things will be, when the number of the NRP is large, will be challenging. So that sometimes maybe we need to have some more efficient channels for some information distribution. And okay, that's that.
Okay. So I think it would help if we go into specifics. So let's try to do that on list, perhaps.
Yeah, we can have more discussion about this part of the text.
Hi, Greg Mirsky Erickson. Actually, I concur with Ketan because this isolate information from existing routing information, that's a little bit vague. Might be following on Ketan's recommendation, more detailed analysis of IGP, BGP, BGPOS would be helpful. Or if you believe that this document should depend on a separate document that analyzes the impact on the routing protocol, maybe that's the way of maintaining the smaller size. So not exploding this document, but having a separate document that analyzes possible impact and recommends certain mechanisms to achieve what you recommend.
Yeah, actually, in this draft, we already have the recommendation about adding scalability considerations in the documents which make this extension specific to NRP, so that each doc control plane or data plane draft, they will have their considerations about the scalability, and so that it's match to check whether they match this design principle here. I think maybe in this document is not suitable to go to the details of each protocol.
Yes, I agree. We definitely don't want to go into adding specific solutions, but when we say scalability, we probably mean specific mechanisms that needs to be used. So identifying these principles, mechanisms, giving reference to existing solutions, I think that would be very helpful.
Yeah, we can give some general recommendation about how to isolate this from the existing information, right?
It seems that just appeal to saying, oh, let's keep in mind scalability, it's a little bit too weak. Thank you.
Just to add on what Greg said, there has to be a specific proposal for us to judge the scalability of it. Just plain text on like we should not do this, or it's really high level, at least for me. So if we have a proposal of what is the information or what is the nature of extension that we are proposing, then we can discuss the scalability of it.
Right, I think that's why I think that part of detailed discussion should happen in the solution drafts. Right? We give the general guideline here and the requirements. Yeah, okay. I think the last page, as we go, make it brief. In the appendix, we added this realization examples and the scalability implications. I will not talk about in detail, but you can take a look at, there are some options of realizing network slicing using either VPNs with a default NRP or multiple route instances for different NRPs, or resource over segments, or the virtual TE networks. All these have their specific scalability implications, so that we are trying to help people to understand the scalability in different dimensions and different planes in the network. Okay. That's all. Any further comments?
Thanks, Jay. I think clearly there's a lot of text in this document that needs careful review and consideration. So we'll try to find avenues that can get you more focused discussion on this.
Okay, thank you.
And also, if required at some point, also we might consider running an interim meeting for discussions if it's, because it seems there is a lot of need of also of discussion, so advance progress in the documents, and then we can have this discussion. Okay, so let's jump to the next slide.
Luis.
The number 6.
Hello, everyone. This is Luis. I will present the latest status of the draft on application of 5G slices on behalf of my co-authors. So, a little bit of history and background about the draft. In the framework document, there were identified a number of use cases. One of those was 5G network slicing. So we are starting to work in different documents on that idea. So the result of that effort was to merge in one single document all the mapping of the 3GPP objects into the NBI-YAM model. So this is basically the scope of the draft. So how to exercise the NBI-YAM model for the slicing, taking into account the objects being defined by 3GPP. This is quite related with the realization draft that was presented before by Christoph. And we have had some coordination as well between both efforts along the time, and you can see here basically the story log of that. So the changes that we have introduced in this version 02, we basically did an overall cleanup of the document, so trying to improve the readability. It's not or was not a simple document, so we are trying to do an effort on improving that readability. We have tried to simplify the document as well, moving some content to the annex, so in such a way that we can keep in the main body of the document something that could be basically better understandable. We also introduced some corrections to the example provided. As said, we are trying to exercise the NBI-YAM model. So for that, we are also taking example based on examples that are defined in the NBI-YAM model for slicing, and trying to exercise them with the objects from 3GPP, as already said. We also added some terminology definitions that are coming from 3GPP, as the EP transport and the EPRP, so that the reader can have an overall context of what is handled in the draft. We for sure updated as well the references to the RFC 9543, so the framework document in all applicable scenarios, and updated the references in general because also the 3GPP specs are evolving, and yeah, we did that exercise. So, cannot change. Try again. Yeah, so we are now preparing the version 03. We received on top of version 02 comments from MED. Those comments have not been yet addressed, so it will be the matter of version 03. We also request at the time of preparing 02 feedback to the working group. We sent a mail to the mailing list, and we have not received any further comments, so maybe we should understand that this is okay, maybe not. But the point here is to encourage all of you to provide comments that could help us to either improve the document or fix any issue, any concerns that you could have. During the elaboration of the new version, we keep continuing working on making the document more readable, because well, it's essential to have this comment understandable for all the audience that could be in IETF, but also audience that could be in 3GPP. For next steps, apart from creating version 03, we would like to start requesting directorate reviews, and we also would like to ask for the working group last call process, so ask to the chairs that. And certainly we need to wait as well to the response from the 3GPP for the liaison that was sent in October 2023. That is we expected to receive the answer on August, by the end of August. So we will take as well that as an input for the new version. And that's all for this draft. Thank you.
Thanks for keeping it short. Any questions for Luis?
Okay, so now I will cover this other draft that is about the network slice controller and the associated data models that could be around the network slice controller. And again, I will do on behalf of my co-authors. So just to put in context this draft, this presentation, and the next one, basically what we will cover here is related to the internal of the network slice controller. So the models that are from the northbound interface of the network slice controller up to the southbound interface of the network slice controller. So the idea is to go through the different models and how they relate and what could be basically the interplay of all of them. A little bit of recap and refresh on the draft proposal. So according to the different models that are being defined and the different features or functionalities expected, we started working on identifying two main blocks, let's say, the mapper and the realizer. For the mapper, the idea would be essentially to consider the MBI YAM model, which is technology agnostic, trying to map into the network resource partition and trigger the realization in the block that we name network realizer. It's important to note that we put here at the bottom of the slide that is coming from a comment from Joel, and basically this reflects that the purpose of the document is not to not standardize or constrain any kind of implementation. It's just to play with the relation of the models that we are defining in around the slicing. Okay, so we make clear the relationship among all of them, all of them. So the models you can see in these points A, B, and C. So we are considering customer views. That would be essentially the MBI YAM model, and maybe also the customer intent topology that will be presented later by Iowa. Also the provider view, that could be that transport network slice YAM, or the OTN slicing, or the NRP YAM. So we have a variety of them depending on the purpose. And then the different models that will go against the controller that are presented in the next presentation. So the updates to this document, the document was adopted before IETF 118. There were a number of comments, around 10 comments, that were received during the adoption process and were documented in version 01. In version 02, we have covered most of them. I will go through them right now, but there are yet two remaining open issues that we expect to cover in the next version. So going to the issues that were raised during the adoption, one of the issues was raised by Adrian with the idea of discussing about if it's, let's say, pertinent to consider the models between the mapper and realizer because of the fact that it could be considered as a kind of internal data model. So here the point is that, well, the NRP is also defined in the framework document in the RFC 9543. So somehow it's being specified. And also anything prevents that the different modules could be implemented by different vendors, maybe because of different portfolio, different technologies, and so on so far. So yeah, we consider this as addressed with the answer that we provided in the mailing list. Second issue, very easy, was the date of on the affiliation of Jeff. This already was done. The next issue was about the reference to connectivity matrix instead of a slice topology. So here, the way of addressing this is considering the draft that will be presented later on by Iowa as a customer topology intent. So we could expect to have some indication from the customer about the topology that the customer expects at the time of realizing the slice. So we consider as well solve with that. Another one was from Adrian, the last bullet here in the list, was the point that the provider view could also be consumed from a network engineer, for instance, from the NOC. And so in the figure of the controller, I will come back just 1 second here. This B interface is now in the new version has also an external access, let's say, so that anyone operating the network relay controller can also have that provider view, can have access to that provider view. The next set of comments, again, raised by Adrian, was the idea of this separation of mapper realizer that in the previous version was explicitly said in the security considerations part. So very, let's say, far from the beginning of the document. So we commented at the beginning of the document as well. So making the reader aware of that separation. The next issue and the following one, the 8 and 9 that were raised by Swami and Kiran, was around the same idea of treating internal models, in principle internal models to the network relay controller, but that said, we consider that could be external as well. So this interface between the mapper and realizer could be external. And the final issue was from Kiran about the, let me check this, I don't remember. The technology agnostic nature of the network relay controller and the inclusion of the realizer component. I cannot remember now how we solve this. Apologies for that. I will put in the chat because I cannot remember now. Sorry for that. But we consider as well solve it. I will put later on in the chat. Sorry for that. So next steps. We need to yet to close on open issues. There were a number of comments from Meta that had not been yet covered, so we need to go through them. And also an issue raised by Adrian about the number of authors. We started to asking for this. So in the next version also we expect to reduce the number of authors in the first page to 5. We also want work to assessing the proposed structure with the progress of the different aspects of slicing, the NRP that we have seen now with G, or the customer topology intent that will be commented by Iowa, and so on so far, and refining the structure based also in initial experiences. So probably this could provide some feedback that could help us to assess, let's say, this approach. We intend to prepare a new version for IETF 1.2.1 and solve all the issues and present to you that update at that point in time. Thank you.
Okay. So any question for Luis?
Are you presenting the next one as well? Are you presenting the next one as well?
Yes.
So while we bring up the slides, so this is a working group adopted document that talks about associated data models on a network slice controller, right? But the working group adopted document, the focus is primarily on the models on the southbound side, and the next document is our models on the northbound side. I mean, they're still associated models, but did you ever consider putting them together in the same document?
This one and the previous one could make sense. Could make sense. So it could be a possibility. I will pass to
go through it.
Well, this figure probably could be evident, and maybe it could make sense to have all the story from the top up to the bottom. Okay. So thank you. So I will present this other draft, which is about the instantiation of network slices in service provider networks on behalf of my authors as well. And the idea here of this draft is essentially to visualize how we can relate the MBIM model versus the network models or the service models underneath. So in such a way that we can activate the network controllers, taking into consideration what is expressed in the MBIM model of the network slice controller. So, well, this is a little bit redundant, but essentially would be, put into the context the MBIM model for slicing with the attachment circuit, service models and network models for realization. So this draft has been presented in a number of IETF meetings. The changes in this recent version, basically we did a test cleanup. This is always needed. And also restructuring a little bit the section. So again, with the purpose of improving the readability. We added tests and references to the service attachment point and the attachment circuit models that were missing in the previous versions. Also, we added references to RFC 9543 and updated the mapping of attributes between the network slice YAM model and the service models and network models. There was, let's say, an update because the MBI YAM model for slicing has been evolved. So we essentially have considered the latest version for how the different models are identified there. And also we have reviewed the parameters in the service models and network models. So somehow with this exercise, we are trying to find potential gaps that could come from the mapping of the MBI YAM model for slicing up to the service models and network models. But, the exercise is done for both layer 2 and layer 3 service models and network models. And we also added a new figure, the overview of data models used for network slicing, which is presented in the next slide. That would be this. So we can see all the, let's say, the relationship of all the service models from the top, from the customer request up to the bottom. That would be the configuration of the devices and the network. Okay. So next steps. There are pending improvements. There are situations that were not considered yet. For instance, the case that the customer requests a service with a service model, but that service is realized with an slice. That could be, for instance, the case that a service model is realized with an OTN slice. We consider that the draft provides useful guidance for this service instantiation because somehow we are going from top to the bottom. And we would like to ask for adoption. We consider that this is ready for that, even though it requires more cleanup for sure. And any kind of comment, suggestion, or concern that you could have is also always welcome in order to improve the document. Thank you.
Any questions? We will run a poll. Is there any?
You're going to ask 2 questions.
We'll be asking 2 questions. The first one is there interest in this topic?
You want to introduce the second question?
Yeah, and the second question is whether, is there any opposition in merging this content with the working group document?
So it looks like we're getting some pretty good support on this and in interest. It's about somewhere around 1/3 of the room participating. Almost everyone saying yes. So let's move on to the next question. Give me one moment. So this question is going to be about merging objections or to merging this with the prior existing working group document. So rather than having an independent document, just roll this in to the existing work.
So if the answer is yes.
Does it say objection?
Are there any objections? So if the answer is yes, it means that you want it separate document, right?
So yeah, Yes means you object.
And then you want us.
So should we need to restart? Objections mean you do not want to do this. So I'm going to restart.
Okay, so yes means you don't want to do this and you want this
Yes,
document to
yes
become.
means you come to the mic and tell us why you think it's a bad idea.
No, but then
And no means if you do not object, then we will move towards rolling this document into the existing one. So just again, if you say yes, queue up at the mic.
And if no, the document will be merged in the previous document. Okay, so yes is you want this document to be
Yeah,
standalone.
yes means come to the mic. And that's okay. If you object, we want to hear why.
So you want to come to the mic without saying yes.
Well, Daniel King, Lancaster. It looks like the other objectors are shy, so I will stand up and raise my objection is that the work has been progressing for quite a long time already.
You're talking about the working group document.
Yes, yeah. And what I wouldn't want to see is that delayed while we try to kind of merge this other document.
Okay, so you're not opposed to the work, but you're opposed to slowing down the existing work.
Exactly, yeah.
That's a helpful comment. Thank you. Any other comments before we close this? It looks like there's a lot of support for bringing this work into the group. I think Dan has an interesting point. We'll have to consider that, or they'll have to consider it. It's on them now. But thank you all.
Thank you. Thank you.
Thank you. Next up. Iowa.
Hi, good morning. So this is Iowa, and I'm presenting again the IETF network slice topology on data model on behalf of the authors and contributors. Just a brief recap, like this model is designed to provide to provide a mechanism for a customer to express a network intent topology on which network slices can be built. So next page. Oh, I can do this. Okay. So here are some updates from the last revision. We presented it at 119. So the main thing is that we addressed many comments received at the 119 and after 118. The first thing is we unified the use of the terminologies, and throughout the document we define what we call customer intent topology, which clearly expresses this is what customer is trying to express, and that's an input given to the network slice controller. And a second change is the model included in the draft is now divided into two separate modules for the based on a modular design and for the ease of implementation, in which one module defines the actual customer intent topology, and the other module is an augment which augments the IETF network slice MBI by adding support for the underlay path for the connectivity construct. And also, in addition to that, we added a new section to describe the reasoning of why we are not considering about reusing ACT-MBN type 2 for network slicing. And within there, we also make clear that the intent is to define this customer intent topology. So this is also to address the comments based on, I think, Matt's comments to make it clear. and also cosmetic updates to align with the IETF network slice and BIER model. For example, some of the definitions like diversity constraints, which previously defined in this model, has been adopted by the network slice MPI. So we just remove it from this model. And also on the text, there's a new use case section in which we added 2 example use cases about customer intent topology. The first one is a multi-tenancy network wholesaling, and then the second one is a realization of connectivity constructs on different segments within a customer intent topology, and this is applicable for 5G RAN use case, as was presented on the last meeting. Next. Oh. I keep forgetting about that. Here are some of the consideration regarding the working group adoption. This draft is a big part of the use cases on which this draft is initiated to solve are mostly transport. When I say transport here, it's OTN, microwave, and WDM, which are all T-oriented. And that's the reason why this draft was initially proposed in CCAMP working group. So check about all the use cases for OTN slicing, but also the authors believe there are possible scenarios like hierarchical multi-domain composite network slices as proposed by Drafter Lee may also benefit by using custom intent topology for underlay resource reservation. And also there are use cases defined, included in this draft that are that are generic and can be applicable to IP MPLS technologies as well. That this custom intent topology could be applicable. If we develop this work outside of the TEAS working group, for example, like if we come back to CCAMP, the fear from the authors is it could potentially risk by creating 2 parallel solutions for the same problem when there's a need to cover generic use cases within the TEAS scope. Also, the model that we propose by this draft is rather technology agnostic, and also it is a complementary data model to the IETF network slicer MBI, meaning that if only connectivity intent is desired for network slice, then this model does not necessarily need to be implemented. However, if we wanted to make use of topology to further customize how the customer would express in terms of resource reservation and also a fine-grained underlay path for the connectivity constructs, this model could be used. So at this point, the authors believe that we will leave the working group to decide the best home for this work. But if this TEAS working group considers the customer intent topology being the best home, then we would like to ask the working group for adoption based on interest that was shown before.
So I think, given that you have raised the point, we are going to start now a poll to see the interest of the working group in this group. So the first is if there is interest, so that's pretty clear.
Mm-hmm.
So I think it's positive, but not overwhelming.
And not overwhelming,
But positive.
Positive. Also, those that said no, also, I mean, also would like to hear also the views later, also all in the list. So let's go to the next one because there's good result. So now is this document, this draft, a good starting point for working on the topic?
So not much different.
Mhm.
Not much different, maybe a few more with less opinion. So I'd say, a little bit tepid of response. Maybe we need more awareness on the draft. All right. Still have a few minutes though.
Okay.
Thank you.
Yeah, so I still have, right, this, so a couple of slides next has been discussed in the last meeting. Basically, just wanted to give a recap about the relationship with ACT and VN. In the VN model, there are two types of VN, VN type 1 and VN type 2. And VN type 1 is mapping to the connectivity constructs. The VN type 2, there's currently a gap as from a network slicing perspective. So this table shows that what we are seeing as VN type 2 model, which is there's a gap exists in the network slicing scenario, and this is addressed by this model. So we also discussed about how many models that this solution should provide, and the conclusion was on option 4, which ends with 3 models. One is the base, the network slice MBI, and what is proposed in this draft has 2 modules. One is the topology, and the other is the underlay path constraints. So it ended up with 3 models and 2 individual drafts. So the next step is to address comments and questions, and I would encourage everyone to take a read of the document and provide feedbacks. All right.
Thanks, sir. Christoph?
Krzysztof Szarkowicz, Juniper Networks. That it works now, yes? Perfect, okay. All right, Krzysztof Szarkowicz, Juniper Networks. On behalf of my co-authors, I will present the update of 5K to deep serve the SCP mapping draft. So basically motivation for this draft. So 5G end-to-end network slice QS is an essential aspect or tool in the network slicing framework. So it is expressed as QS profile in 3GPP data model. Then it's reflected in the SLO, SLA template in the draft IETF networks slice YANG model. So the primary goal of this QS networking slicing is to ensure the specific performance requirements like latency, reachability, throughput, and so on and so on. So we express that in the QS templates and QS models. So this document provides an example of possible mapping of 5K values to the SCP marking, as well as some grouping that facilitate the enforcements to the 5G network slice end-to-end. So again, this document is informational document. It's not a standard track document, so we're not trying to standardize here and the specific DSCP values and this kind of stuff. It's just informational. Yes, it provides illustration purpose only and should not be considered as deployment guidance. So it's not standard track. So 5QI QCI, so 5QI in 5G, QCI in 4G. This is the number. It's a scalar value to differentiate QoS characteristics 5G systems. So mainly in the RAN system, radio access network. 5K includes parameters such as packet delay, budget, packet error rate, traffic characteristics. So there are many 5K as defined by 3GPP, 5K values, exact values like 82, 83, 70 something. And behind the values, there are some specific requirements like, delay, packet error, and so on and so on. So if someone is using 5K 82, I don't know, then this and this parameters needs to be fulfilled. So this is the specification from 3GPP. And then the question is, when we start to transport the RAN traffic or this 3GPP traffic over IETF transport network, then of course the question is, and we know that in IETF we are using DSCP for similar purposes that 5K is used in the RAN by 3GPP. So what is the correlation between 3GPP 5QI and IETF DSCP? Do we correlate somehow and so on? So this is the questions here. I think Greg has a question.
Yes, Greg Mirsky, Ericsson. So can you clarify, so you believe that DSCP expresses latency experienced by packets, packet loss, bandwidth?
Well, not exactly, because we say that if expedited, for example, expedited forwarding DSCP value, yes. So it expresses that we should provide expedited forwarding for such kind of traffic, which of course has influence on the latency. Probably that will be the minimum latency traffic for this network.
But there is, okay, so can you give an example where there are specific latency bounds associated with DSCP behavior?
There is no.
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 Okay, is there any example of DSCP value being associated with a specific bandwidth reservation?
No.
With the packet loss?
No.
Okay, so basically the only that I know DSCP associated with the local scheduling policy, not with their particular bounds and
Correct.
SLEs.
Correct.
So, but that's not what 3GPP expects.
Correct.
So how you map from 3GPP to DSCP, which is a local scheduling policy?
Yeah, we have some slides later on about the mapping.
Okay, because my understanding is that what this document position is that DSCP can be associated with a specific resource allocation.
Well, not resource allocation. This is for the treatment of the traffic. If how the traffic can be treated in the transport network, in the network. For example, EF is treated better than BE, DSCP. So
you think that it's sufficient richness to map to 3GPP behaviors and expectations?
No. It's only one aspect, yes. Of course, we have network resource partition, this kind of stuff, but still we need to handle DSCP somehow, or we say that, all the 5G traffic is single DSCP value.
So you think that IETF network slice can be sufficiently mapped to 3GPP without explicit network resource partition selector?
Could you repeat the question?
So that IETF network slice can be mapped to 3GPP behavior without explicit network resource partition
yes,
selector?
Yes, of course. We can implement 5G slicing without explicit NRP selector.
Without?
Without.
Okay, let's see.
If I may. Yeah, so coming back to what some of the things that Greg was asking, and the base of intent for this particular work, as I understood, is that you have one NRP here. So you don't have, you're using the existing network, no forklift. So it's a good thing here is in being able to map to per hop behavior through DSCP is a good attempt. But then also you have routing in addition to satisfy your other intent on top of what QoS or per hop behavior can give you. So you still have FlexAlgo policies. You are doing routing based on the intent of the service. So I do believe that this could be satisfied, like Christoph is saying.
Great. Thank you much. Thank you.
Jadon from Huawei. I'd like to understand the scope of this mapping. Is it for the different priority or traffic class within IETF narrow slice, or is it?
There are some more slides, which is just introduction. Yes, I have some more slides which explains in more details the scope of mapping.
Okay.
Right. Okay, so scope here uses scope of the contribution. So we have IETF transport mapping and queuing scheme. So in IETF transport, we have some queues and we can map, the traffic to these queues and so on. The question is how we map the traffic to the queues. This is typically based on the DSCP values. In case of IP traffic, in case of MPLS is traffic class values. So we are limiting here to the discussions to the IP only. And now, so draft Henry, TSV, WG, diffserv to QCI was discussing kind of similar problems, similar discussions for 4G, so QCI to DSCP mapping. We are discussing here extending in this draft to 5QI to DSCP mapping. And as well, apart from 5QI, we have another type of traffic in the network. So it's not only 3GPP traffic, but we have, for example, front-haul traffic. We have some management traffic. Maybe we have some traffic related to the distribution of timing and synchronization, so PTP traffic, and so on and so on. So we know that in the existing networks, we don't only carry 3GPP traffic. All right, so this is as well taking into account in this draft.
Do you want to take David's question now? I believe it's on.
All right, David.
So David Black, I was one of the chairs of TSVWG at the time that Draft Henry was considered. Draft Henry is expired. It basically dead. It's like three or 4 years. I don't think it's going anywhere. I've not seen any signs of anybody wanting to revive it. So I would encourage evaluating the draft being presented here as a standalone, as opposed to as a complement to Draft Henry.
Okay. I think I didn't fully understand because the quality of the voice was not so good.
I think David was pointing out that draft Henry is expired and you don't need to tie this.
Okay, I see. All right. Okay, thank you. Thank you for the comments. All right. Okay, so we have some reference here in the draft Henry, but maybe we'll change that. So basically, in the draft Henry, just for the historical, yes, for the some of the historicity. So in draft Henry, this mapping was not always straightforward. So we have some QCI values mapped to some DSCP values. And there are two mapping approaches. So one is one-to-one, like draft Henry is using. So one value from QCI is mapped to the DSCP value. In the second approach is 5QA based on the grouping. So again, the full problem is that, let me step back a little bit here. So the problem is that with 5QI, QCI, we have like, I don't know, let's say 80 values, 60, 70, 80 values, something like that. And in typical hardware that we have in the IETF transport network, we have like 4 to 8 queues. So let's say we have 8 queues. So the question is how we use these 8 queues to carry these 80 5QA values. So this is basically the question, okay? And that's the reason there's one-to-one mapping. So we need to group in our approach here that we present in this draft. We are grouping multiple 5QAs to groups, and then we assign this group to the queues. So we have limited number of queues. We don't have 80 queues. We have only, let's say, 8 queues, and we are grouping these 5QAs to queues. So we are proposing, again, this is the framework. This is not the standardization as such. This is an informational draft, not a standard track draft. So we're proposing to group entire spectrum of the 5QA values to certain groups, limited number of groups, like 4 groups. So group number 1, as an example, is the group that is grouping the 5QAs with low latency. Okay, this is group number 1. Group number 2 is grouping the 5QA values with the medium latency, and then the remaining 5K values is divided to group number 3, group number 4. Group number 3 is remaining GBR, and group number 4 is remaining non-GBR. So this is an example. This grouping can be changed. Yes, so we have certain 5K values in group number 1, but maybe based on the particle deployment and so on, this grouping can be changed. And then we are mapping this group to the queue. So here's again some example of typical hardware queuing in the router with 8 queues. One queue is priority queue, remaining queue is the bandwidth queue with the round robin or weighted round robin, something like that. And then you see here this 4 groups, 5K groups, group number 1, group number 2, group number 3, group number 4, mapped to certain queues. And we have additional traffic apart from 3GPP traffic, which is grouped for these 4 groups. We have as well network control traffic, like we need to carry, I don't know, ISIS, BGP, LDP, whatever we have in the network control. Then we have as well traffic to distribute the synchronization clocks, some PTP traffic. If this is part of the network, then we have the front haul. We have front haul traffic as well, and so on and so on. So this is again some example. This is not the deployment guidance, but this is an example that we provide for better understanding of how can we handle the QoS models. All right, and the next steps is to assess the convenience of the approach of mapping 5QI to the SCP. So this is ongoing. Then provide information examples about the proposed methodology. We provide already some examples in the draft. Based on that, consider the implication of realization model for slicing in IETF. Better understand the implication of 5K aware and unaware connectivity models described in the realization draft. And then to BD, present the draft to the SWG and follow up the discussion initiating during IETF 120.
Swami.
Thank you.
Swami Nokia. So if you can go to the previous slide. So is the assumption in the groups that the way the packet is treated in the network, if you belong to the group, would be kind of similar? Because
yes, so as I mentioned before, yes, group number 1, this is we are grouping 5QI with the low latency requirements. Okay, this is group number 1.
I mean, my personal feeling is that this is kind of a necessary condition, but not sufficient, because if you see in a 5G slice, right, within that you would have packets that have higher and lower priority, right? And,
right.
And at some point, you will not have to make a decision on how you are going to drop the packets, right? And then it doesn't come back, right? So,
yeah.
I mean, to me, just as an implementation, you might have a stack of priority queues, right? And
yeah, but we still have 8 queues. Yes, we are talking about 8 queues.
I know. So
and let's say 85 QIs. So we need to map these 85 QIs to 8 queues.
Okay, so it's interesting, but I think more is needed there, right?
Yeah, this is initial draft. This is revision 2. This is at the very initial stage at the moment. Okay. So we are welcoming all the comments.
David goes next. We have actually locked the queue after David, correct?
Okay.
So David, you can go ahead.
Okay.
We can come back to the order.
Okay. Relaying a little bit of discussion from the chat and providing some context. In the past, 3GPP has cared intensely about this space. That's that's among the reasons Draft Henry went nowhere. That 3GPP cared intensely and didn't like what they saw. As Charles and I have commented on chat, 3GPP might have a different attitude, positive about this draft. It will be vital to consult 3GPP via a liaison statement if this draft is going to be adopted by the working group, because Draft Henry just went off the rails courtesy of 3GPP opposition. I will say on a technical point, I do like what I see here. This draft is considerably less aggressive in its use of DSCPs than Draft Henry was, and I view that as a positive.
Yeah, of course, we are open for liaison statement to 3GPPs. Thank you very much.
feel, yeah. Greg Mirsky Erickson. So yes.
Greg, we don't have time.
Okay.
If we have time at the end, we can.
So good morning, Paolo Volpato. Away, I'm presenting, I guess, the last draft in the agenda on behalf of the authors you see here. So just one quick word on the relationship between this draft and the POI, ACTN POI. So basically, that is the further document. There, the TE cases are discussed and instantiated. There is this second draft I'm presenting right now about assurance, which is a sort of, let's say, add-on to the original ACTN POI, because we decided to deal with the assurance cases that couldn't find space in the original document. You see here, so basically we are still dealing with a traditional IP and optical split. So there are two layers providing services. It's a kind of normal multi-layer network. And this draft called POI assurance deals with how to, let's say, detect, localize, handle the failures, the false cases that you can find and possibly fix them. Now, about the new version that we uploaded quite recently, the main differences are shown here. So while the previous version focused on the mechanisms to try to fix the issues, this time we focused on the multi-layer fault management. There are a few scenarios that I'm going to, let's say, introduce to have the feedback from the community. There are still some open areas in the draft, so maybe I'm anticipating the request to have the support from the working group on, let's say, progress the document with the missing parts. Now, about the scenarios, you see here basically the two layers connected. Since we are dealing with what I call the traditional network, the interfaces between the IP layer and the optical layer are still gray interfaces. You see that we tried here to focus on the exchange of messages between the two layers and the components belonging to either of them, and on the messages that the network element sends during the occurrence of a failure to the physical network controller, and in turn from the network controllers up to the MDSC. The MDSC is considered as the point of, let's say, consolidation of all the events, the messages, the alarms, and it's the, let's say, the element then eventually triggers the protection and the recovery mechanisms down to the physical networks, to the physical layers. Now, let's maybe focus on this first scenario as an example to, let's say, bring ahead a discussion. Then you find all the other scenarios in the presentation and you can clearly look at them afterwards. You see there is a router called R1. It's connected, for example, via two unidirectional fibers to an optical network. The object called the PE1 is not a provider edge router, so it is not to be intended as an IP element. Sometimes you use that names just to, to be quick in the discussion, but actually is a ROADM, so it's an optical element. The two of them are connected, as I said, through two fibers, through two segments, two unidirectional fibers, for example. One of them has a failure, so there is an issue. Connectivity is broken. So looking from the perspective of the optical network, PE1, as I said, a ROADM1, immediately detects there is a loss. So loss is sent to the optical network controller, which in turn sends a notification to MDSC. Across the optical network, there is a kind of exchange of messages. For example, we see a client signal fail, which is propagated internally to the network. It reaches the border of the optical network, so PE2, again, ROADM2, if you want. And then we have a local failure indication to the router at the end of the connection. You see also the exchange of messages on the other way around. So moving back from R2 to R1. What is important, I'd like to highlight. Our assumption is that all the network elements are sort of capable of understanding the messages which are exchanged. In the text, we have tried also to, let's say, discuss the cases when a router is not able, for example, to detect at the, I would say, at the physical level, the LFI message. In any case, R2 is informed of something that happened in the network. You see that there is a yellow arrow going upwards to the physical, to the packet network controller. Can be an LFI status if it is capable of understanding the messages at the physical level, but also ABF down indication, meaning that at layer 3, so the IP layer, the connectivity is lost. That is the mimics we have foreseen. Then there are also the other scenarios, but I said I want to be quick, so there is no need to explore all of them. So you can easily take a look afterwards. So that first example was the ingress case, again, having the optical network as the reference point, so as the observer. Then we have the egress case, which is a sort of a dual scenario to the previous one. The point of failure is between ROADM 2 and router 2. Then we have another case, which is the full failure, I would say, in the connectivity, in the connection between R1 and PE1. Clearly, you see the messages changes according to the scenario, but basically, again, it's a notification to the upper physical controllers and then to the MDSC. And a final scenario for which maybe could be important to have your feedback is something happened within the optical network. So the two routers at the extremes point at the extreme points simply are notified of LFI, or maybe they simply understand through the lack of BFD messages exchange that something happened. Now, so that just to conclude the presentation, I would say the next version will continue the discussion on the assurance scenarios, on the protection mechanism, recovery, and so on. We are fully aware that then there will be the biggest part of our work, which is the definition of the Yang data models at the MPI. It will take some time. So we do invite everyone to join our discussion. You can easily send a message to Italo or Prasenjit that they are dealing with the organization of our weekly or bi-weekly calls, depending on the period. There is also a GitHub available, so I do invite everyone to take a look at that. I would say that's it.
I have one question, Paolo. The work is expected to be focused on the young media models on the MPI, so it's all, let's say, young models between controllers, or do you foresee that there will be requirements or extended requirements for the communication between the network elements and the controller, and other protocols that are not the communication between the controllers, just to see if the scope of the work is widened or constrained to this?
Right. So my first answer is for sure we will deal with the MPI at first, but clearly we do, let's say, accept any indication to widen the work if necessary also to other.
Yeah, no, that's based on the analysis that you have made, is if what is available already down at the network elements and or at the protocol level is sufficient, and then it's just MPI, or if not, you detect also gaps, and then there is further work that needs to be done.
For sure.
Thank you.
Okay. Just an advertisement that I just noticed that you have mentioned that the performance monitoring is to be done in this draft, and currently I have a draft which is about resource PM, which is still working on, and I think that draft is both applicable for IP and optical technology. I think it would be very suitable for this service assurance. If you want some more contribution, I would like to join the discussion.
For sure. You're welcome.
Yeah.
Hi, Italo Buzzi. A question to Oscar. For when you talk about the SBI, I think at least in the optical domain, the vast majority of the device models are proprietary/vendor specific. So I think we definitely don't need to touch. So do you would like to us to touch the
IP also?
On
Because,
the IP
yes,
side?
because you put it in the slide that also there was some BLT
Yes.
communication, there were
Yes.
some,
So
I guess there will
yes.
be timers involved
Yes.
when triggering one restoration in
Yes.
one and the other.
So one
maybe,
option is that what we say is that the device model for the MBI or for the optical device is out of scope. It's up to the optical PNC domain to care about that.
Yeah.
We can extend the same option to the IP, say that it's up to the IP PNC and the router to figure it out, or you want us to go into some existing YAM model for SBI?
What I would like to know is if there is gaps in the existing, in that part with the IP, if there are gaps and then they need to be addressed, or if it's
Well, if it
sufficient.
is vendor specific, I cannot know.
No, if it's vendor specific,
So you
of
would
course.
like us to analyze the standard YAM models,
Yes,
define
well,
IETF for that, and say if there are gaps. Okay.
YAM models and protocols if necessary.
And
Because
protocols.
sometimes
Okay.
it could be protocols.
Okay. Thank you.
Okay, thank you.
We're out of time.
Yeah. So thank you very much for the session.
Sorry, we are out of time. Can you please take that to the list? Thanks everyone for a very productive session. I'm going to ask Lou to close the session out one last time.
Thank you all. Appreciate the great session. Look forward to seeing you at the next meeting, although I won't be sitting up here. I'll be sitting back there, but you'll be in the excellent hands of Pavan and Oscar, and look forward to their future great leadership. So thank you.
Thank you.
Thanks, guys.
So now we have some.
Now it's on you.
Yeah, no, we have some. Let's see. And there are other things to do there, but I think it's interesting and if someone talks to our network and they have their own specific values, maybe it's clear that it works needs to be done.